Alright, it's time for our next video, and this one is about pollution control, and it begins on page 421 in your textbook. Remember that anytime you're asked for what's the best solution to any problem, it's use less of it in the first place. But that's not on this list. What is on this list is all of the things that we do to deal with the air pollution. We have laws in place, and obviously when you're thinking of air pollution control, you should be thinking about what have I been talking about all these days and days. Smokestacks and tailpipes. So we can talk about using less. We can talk about preventing the pollution in the first place. We can talk about technology. We can talk about improving existing science to do a better job controlling air pollution, and then of course lastly some innovative neat ideas that have come down the pike. So you need to be familiar with each one of these different techniques. I've never seen it asked, the inside out of how these things operate. So I don't think you need to memorize how a baghouse filter works or how an electrostatic precipitator works, but you sure do need to know the terms. You need to have heard of them. Alright, well, let's start first with removing sulfur and nitrogen oxides from coal exhaust, and we do that with something called fluidized bed combustion. And again, this is about familiarization. You need to be able to name this as a way to remove sulfur. This process happens during the burning process, during the burning of the coal, and in close proximity is calcium carbonate, and that helps to reduce sulfur dioxide emissions. The heated calcium carbonate absorbs sulfur dioxide and produces calcium sulfate. This is a powder. So this fluidized bed combustion makes a powder that is called calcium sulfate, and it is used in gypsum. Gypsum, you might know, is that white stuff that's in drywall. If you've ever seen a wall go up onto studs, sometimes it's called wallboard, sometimes it's called drywall, but it's made up primarily of gypsum. So this is a 2-for-1 deal. We don't have to mine the gypsum to make wallboard, to make drywall. We can take the calcium sulfate that's made during fluidized bed combustion, and we can make gypsum out of it. Now for the nitrogen, it's all about reducing the emissions by reducing the temperature of the burn. So many times what's done is the amount of oxygen or the amount of temperature is controlled during the burning of the coal to decrease nitrogen that gets into the atmosphere. Nitrogen, sulfur, and carbon monoxide are all controlled by catalytic converters. Carbon monoxide are all being controlled by the catalytic converter that's on your car. And what I tell you, always remember that usually it's the nitrogen that is it's least effective on the nitrogen. So practically no sulfur gets out of your tailpipe. Yes, CO gets out of your tailpipe, and yes, nitrogen excuse me, yes, nitrogen gets out of your tailpipe. In addition to that, so we've had fluidized bed combustion, we have the catalytic converters on cars, and then these three things are all about smokestacks. And the first is simply called a scrubber. I've got diagrams to show you of all that. Scrubbers, these are all three things that are inside the smokestack: baghouse filters and electrostatic precipitators. Remember I told you in the first video, any kind of smoke that's coming out of a smokestack, there is particulate matter. That is the biggest concern, it seems, to clean up what's coming out of smokestacks, is the PMs. We got to get rid of the particulate matter because we don't want that building up, landing on people's houses as soot, you know, and you don't want to be living down the street from a power plant and you have it build up on your cars, etc. So this is an emphasis to get rid of PMs. There are some applications for getting rid of other chemicals. So let's go to them right now. Here is the baghouse filter, and as I just mentioned, it is designed to clear out particulate matter. And it's just a filter bag. It's not unlike your vacuum cleaner at home. Okay, the dirty air comes in, it goes through these bag filters, the solid material gets trapped by the bag, and what comes out is clean air. Then those bags have to get cleaned. So let's see, dirty air enters, combustion exhaust streams, moves through, the dust particles are trapped, cleaner filtered air moves out of the unit, and a shaker mechanism is activated to periodically dislodge the trapped particles so that they can just be collected at the bottom. That way you don't have to change the filter over and over again. Very simple operation, used primarily, as we said, for particulate matter, PMs. Here is the electrostatic precipitator, and as it sounds, electrostatic means electricity is used, and sure enough, what happens here is the dirty air goes through a charged container, high voltage negative electrode, and so that kind of makes all of the solid material negatively charged as it goes through here, and then there's a positive electrode further down the pike. Now that these particles are negatively charged, the positive charged plates collect the dirt, and that collection hopper here is at the bottom. So this is about PMs as well, but obviously if there are other chemicals that are involved that might have a charge associated with them, they could be captured as well. The most popular air pollution control device is called the scrubber, and this is also done inside the smokestack. All three of these things are done inside the smokestack. Dirty air enters the scrubber, and as you can tell here, we use a whole lot of water. We use water to literally wash the solid, tiny little solid materials that are in the dirty air that's coming up. During that process, the particles are scrubbed and they drip down where they are collected in the bottom, and then they're turned to sludge and they're getting taken to the dump. So all three of these are used in air quality in smokestacks. Now, what do I want you to remember about this? First thing I want you to remember is a lot of energy has to be expended to get here. As a matter of fact, some environmental scientists say they're not sure that a scrubber, with all of the water that gets used and all of the electricity that's used to run this motor and this engine and everything, is even worth the amount of pollution that it cleans out in the end. Because remember, there's a negative to every environmental solution. Same with electrostatic precipitator. You can imagine how much electricity this uses. Well, all that does is put more chemicals up into the air through the smokestack because all this electricity has to be used. And even going back to the baghouse filter, this pumping process, this is the least of the energy users, but this shaker mechanism runs on electricity. You can see the motor up here. So no matter what we talk about with these cleansing activities, they use energy. And if they use energy, that means we're having to pump that much more up through the smokestack at the power plant. Having said that, these techniques are very important for cleansing PMs. They also cleanse an awful lot of sulfur. Okay, I promised you a third look besides these technological advances. Let's talk about innovation. Let's talk about some of the new things that we're doing today. All right, it all begins with focusing once again on either the smokestack or the tailpipe. It includes focusing in on people's activities. One of the problems that we find associated with a lot of the air quality problems that happen in small towns, in places like China and in Mexico and even in England, is changing individual people's behavior to come up with a positive result. In that vein, then, some towns and cities have actually taken to restricting the use of lighter fluid on charcoal grills. A lot of VOCs are released when we use the lighter fluid. We can decrease gas spillage, which happens a lot, especially in developing countries. Here in the U.S., we have those black rubber caps that you see at the gas pump when you put your gasoline in your tank. Those rubber sort of gaskets help to prevent spillage. As soon as gasoline gets airborne, those vapors end up in the atmosphere, and so we want to decrease that as much as possible. Anytime you burn anything, these chemicals are released. So in a lot of towns and cities, they talk about decreasing the usage of wood-burning stoves, and especially in developing countries. In the book, they even talk about things like some cities in California actually controlling the amount of bakeries that operate, because bakeries pump a lot of sulfur and nitrogen up into the air. So those are some things that everybody can do at home. And of course, one other thing you can do at home is you can drive less. All of these different techniques are interesting ways that we can decrease emissions from the tailpipe. Obviously, here in the U.S., we're not going to do this, but they do it in Mexico. They have odd and even driving days. If your license plate ends in an odd number, you're allowed to drive today. But you're not allowed to drive that car tomorrow, because that's for the even numbered vehicles. This cuts down the number of vehicles on the road in half. It may not cut down the number of miles driven, but the theory is less emissions in the air. Obviously, if we enhance the value of people using carpool lanes, we're saving big time. You remember us covering that when we talked about city planning. That is a big saving when you can have 2 or 3 people ride in your car, assuming all 3 of them would have driven their own separate vehicle. You've cut down 2/3 of the emissions by carpooling with 2 other people. Other ideas that have come along: toll roads. Make it expensive to drive into the city. If you make it expensive, maybe people will think twice about driving into town. And also increase parking. Same idea. If you make it so unpalatable to park in the city because it's so expensive, you might use public transportation. Sulfur credits, one last thing I wanted to hit on, is a really big deal, because we can talk about this in terms of sulfur credits, or we can even talk about it in terms of carbon credits. George W. Bush introduced a program called Cap and Trade, and that'll be on your quiz tomorrow. Cap and Trade. And the deal with Cap and Trade is some companies are going to come in under their cap, and some companies are going to come in over their cap. If you're a company that comes in under your cap, you can sell those credits, that amount of sulfur that you didn't burn, to another company that can't come under the cap. How does this save sulfur emissions? Because the caps are set up so that it decreases all of the sulfur emissions from last year. So your cap is going to be less than last year. My cap is going to be less than last year. And that's our top end. You see, this gives us a financial incentive to come in under your cap. Because with these credits, you can make money. The whole concept here is to try to use the free enterprise system to motivate people to do the right environmental thing, to motivate companies to do the right environmental thing. So if your company comes in under your cap, you can sell those credits to somebody like me. Maybe I'm not as innovative, or I haven't come up with a good solution for my sulfur emissions yet, so I can buy credits from you. You make money. You see, you have a financial incentive to decrease your sulfur credits. And now it's costing me more to operate my factory. I now have a financial incentive to find out what it is you're doing so that I can decrease my sulfur emissions. And if everybody decreases, the government will pay for those credits. Next year, the caps will be a little bit lower than they were this year. Every year the cap comes down a little bit, and so we slowly decrease the amount of overall sulfur emissions this way. It's an interesting idea because it uses capitalism to solve an environmental problem. I don't think I need to go over this motor vehicle solutions thing, but it should not surprise you. I think maybe we've talked about these before. Prevention is always better than cleanup, so we can prevent motor vehicle pollution by using mass transit, biking instead of walking, use less polluting engines or less polluting fuels like natural gas, improve your fuel efficiency. It's always a big one. Get better miles per gallon. Get older cars off the road because they don't have the latest innovations in their catalytic converters. And give buyers a big tax write-off to buy, let's say, for instance, an electric car or something like that. And we can restrict driving in polluted areas, which they do in places like Mexico City, where there are some days the air quality is so bad they just put barricades up and no cars are allowed in the city that day. What can we do in terms of cleanup? We can add emission control devices like California did to me. Remember my story? Making you add a second catalytic converter so that what comes out of the tailpipe of the car in California is even better than what comes out of the tailpipe of a car in Florida. Car inspections, I talked to you about that as well. Another technique that's oftentimes used. They actually measure the what comes out of your exhaust pipe, and if it doesn't meet certain specific regulations, then they require you to go to a car shop and have your exhaust system fixed. And then we can make our emission standards even stricter. Okay, here is a few other things to talk about. I already mentioned the cap and trade, so I guess I don't need to talk about it again. The Clean Air Act is one of the important laws for you to remember. I already talked about cap and trade. Clean Air Act is an important law for you to remember, and it sets standards for how much of a particular pollutant is allowed to come out of smokestacks and allowed to come out of tailpipes. Be familiar with this acronym. This will be on your quiz. National Ambient Air Quality Standards were set by the Clean Air Act. All right, there are primary standards and secondary standards. Here's what I want to tell you about the Clean Air Act. It did it did three things. It set primary and secondary pollutant standards. it named the chemical and said how much is allowed to come out of a smokestack and a tailpipe. The Clean Air Act, this is 1970 by the way, the Clean Air Act also took the lead out of gas. You remember, I think I've told you that story before. If I haven't and you need to hear it again, let me tell you that story again about unleaded gasoline. It took the lead out of gas by law, and then it required the addition to all exhaust systems of catalytic converters. You know, the funny thing is, a lot of people were really against these catalytic converters, complaining that it hurt their gas mileage and that they caused, because they hurt gas mileage, they caused more pollution than they cleaned up. Of course, all of that's what you hear whenever something new comes down the pike, and it, of course, turned out to be completely untrue. Catalytic converters are a vital part of your engine now to control what comes out of your tailpipe. And then the third thing that the Clean Air Act did was it established CAFE standards. Remember what CAFE stands for? Write it down. Corporate Average Fuel Economy. And that's that miles per gallon thing. Remember, back in the day, we'd never heard of that until 1970 came along. We'd never heard of anything like miles per gallon. Who cared? Gas was 30 cents a gallon. We didn't care about how many miles per gallon we got. In fact, a lot of our cars got gallons per mile. We used up gas so badly. Our engines were so inefficient. So the introduction of CAFE standards made car manufacturers average across the entire fleet of cars that they made come to a certain MPG. One other thing that is something that we can do is we can build higher smokestacks. Now this does nothing to decrease what comes out of the smokestack. But if you lived in a town with a bunch of smokestacks, don't you think it would benefit your breathing air where you lived if the smokestack was higher? It just makes common sense. You need to remember that a higher smokestack doesn't mean less emissions, but it does get the emissions higher up into the air and increase the likelihood that the jet stream will pick it up and slowly but surely just kind of dissolve it and move it on. Remember, there is no away, but higher smokestacks can be a pollution problem near the site of where the smokestack is. I believe that's all for the prevention and solution section here. No, there's one more here, just emissions reduction from smokestacks here. One overview slide. I love to include these little overview slides because no matter what I say, it hits the highlights for sure. Low sulfur coal, we've already talked about that. Anthracite is low sulfur coal. We can also remove the sulfur from the coal. Now that takes a lot of energy, but some power plants are doing this now where they're putting the coal through a process and they are eliminating the sulfur from the mix so that when they finally burn the coal, no sulfur is coming out of the smokestack. Convert coal to a liquid or a gas, same idea. When you convert coal, you take the impurities out and you're still burning it, so you're still getting the advantage of the energy that's inherent, that's inside the lump of coal, but you're cleaning the impurities out. Or we can use less polluting fuels like nuclear. Here's a nuclear power plant here. Or we can try cleaning up. Disperse emissions above the thermal inversion layer. Taller smokestacks. That is actually a solution. We can try removing the pollutants after we burn the substance, whatever it is, coal. But that's very tricky, and our technology hasn't changed much over the last 30 years or so. We have the baghouse filters, electrostatic precipitators, and the scrubbers. and here's that tax each unit of pollution produced. You know, that's very unpopular, because a company, in order to make a profit and do what it does, needs to emit some stuff. They don't feel like they should be taxed on their emissions. All that's going to do is raise the price of whatever it is they make to the consumer. Something like cap and trade is something that's a little bit more palatable because there is a financial incentive built in. Okay, that is how we clean up our air quality issues. Now, the next section is all about ozone depletion. Not so much an air pollution issue. I want you to remember ozone depletion as a totally separate issue. That's why it'll be in another video coming up. Have a good evening, sports fans. See you later.